This program was produced by the Chemical Heritage Foundation. Our mission is to collect, preserve, and make known the history of chemistry, chemical engineering, and related sciences and technologies.
Could I go to the slide for next month first? Before I introduce today's program, I want to tell you about next month's program. We have one of our own, Ed Richmond, who is an entrepreneur, started his own company, the Richmond Chemical Company, and he's going to tell us an entrepreneur's story, one entrepreneur's story. It's in January, and we hope all of you can come. It's rare that we have one of our own who attends practically all of the JPS programs here share his message with us. For today's program, as I indicated earlier, we have a panel symposium. It's going to be moderated by Tom Tritton, who all of you know is the former president of Chemical Heritage Foundation. Prior to that, he was at Haverford College. But he started his professional career as a professor who had to obtain funding for research. So he knows very well the message of funding and what's required for funding going back quite a few years. And he was enthusiastic about, when I asked him to chair this or moderate this session, he was enthusiastic about leading this discussion. So it's a pleasure to welcome Tom again. He knows this stage very well. And also our three panelists, if they would come up at this point, I'm going to leave it to Tom to introduce our panel.
Thank you, Tom. I'm pretty sure that nobody in this room would doubt the contribution of science to human progress. Much of what we take for granted in contemporary civilization, everything from electronics to telecommunications to medicine to all kinds of new materials to soft robots, if you were here last night, is a result of scientific progress. But that's the past, giving us a pretty nice present. Question in some ways for today is, what about the future? Especially, what about the future? Can we expect to continue with this kind of progress in an environment that has less and less resource to devote to the scientific enterprise? So before you see the panelists who are going to discuss this, and I'm not even going to introduce them because you can read their names in front of you, and they all sat at the right place. That was good start. And you can also read all about them in the program, so I won't go over that, but they do have a fascinating story, so I would recommend that you read that. Together, I think the four of us, I hope they take this in the right way. I'm going to characterize us as practical academics. What that means is that we all have been involved at some high level in running our own research programs, albeit in different fields, but also in various ways in leadership roles and trying to enhance the scientific enterprise in ways beyond just our own research efforts. So I think together we probably have a decent chance anyway of catalyzing a good discussion about the topic today. Tom referred to my past when he introduced me, and when I started as an independent investigator in the early 1970s, the NIH, which was my principal source of funding, was funding at a rate of about 50 to 60% of approved applications. Basically, all you had to do then was to have a good idea and be able to string together a few sentences with the punctuation in the right place, and you got funded. That seems utterly impossible these days to anyone who relies especially on federal or foundation grants to conduct their research. And even over the time that I spent as a researcher in the 70s, 80s, and 90s, that began to decline to in the 10% range, and now it's probably more closer to 5% of approved applications getting funded. There was one period when I was serving on an NIH study section, which makes the decisions about which grants are good, that we actually had a serious discussion about boycotting doing that job, because we didn't believe that we could do it fairly. When you're asked to pick out the top 3 or 4 or 5 or 6 out of maybe 100 grants, when probably 20 of them are equally worthy. We didn't end up boycotting it, but you can appreciate the dilemma that happened. And that experience led me to develop what I'm going to call for today the 5-minute theory. And my theory is that if you put any two scientists together of any stripe, that within 5 minutes, they're talking about their funding problems. Maybe we can put that to the test with these people. And that's a shame, because what they should be talking about is their work. And they do talk about that. But it's become so dominant that it's a dominant part of the competition in the modern landscape for science funding. And I hope we'll have a chance to explore the ramifications of that today. So here's how we're going to do it. I've asked each of them to talk for about 10 minutes. That means they'll probably go over. But a short little bit of time about their own backgrounds and their general perspectives on the topics and the ramifications of the topics that are before us. And then we're going to go to part 2, where I'm going to ask them some questions based on what they said, or maybe based on what I think they might have left out that could be pertinent. And then part 3 will be your part. That is, we're going to open it up to questions from all of you, because that's probably for most of you the most fun part. Now, in order to not preempt that, I want to give you the opportunity after each of them talks. If you have one burning question that just has to be addressed immediately, we'll do it then. So that's a pretty high standard, but we'll do that. So remember, after each of the talks, you'll have the opportunity to ask a question. So we're going to go in reverse alphabetical order, which worked out nice because it means Kate is first, and she's closest to the mic. So without further ado, from the University of Pennsylvania, Kate Stebbe.
Let's see. I'm up. So it's now good afternoon. We just made it, right? It's my pleasure to be invited to speak to all of you, and given the knowledge that all of you have, to hear your ideas about how academics and industry can better connect. I think it's a very interesting time. For most of my career, these connections were happening sparsely around the country, and they've seemed to be happening more and more now. There were a couple of really very strong, attention-grabbing moves, and I'm thinking of one in my field. I'm a chemical engineer, where there was a company that staked its territory and made very strong partnerships with select departments across the country, and captured everybody's attention in saying, this is a great idea, that this is a great idea to create partnerships where we can collaborate to effectively address problems that will help society. So that's really the context in which I think about industrial academic collaboration. And sometimes the first question you get from people is, can this be done appropriately? Can we do university appropriate research that is sponsored by industry? And I think I'm a chemical engineer. The job of an engineer is to make things that are going to be implemented and to help society. And I think absolutely this can be done appropriately. My own PhD was a very fundamental study of multi-phase flow in capillary tubes. It garnered me an award from the American Physical Society for significant contributions. It addressed a problem that was at the crux of, it was a precursor to a microfluidics device for medical diagnostics. And there was a hydrodynamics problem there that made no sense. Things that were supposed to go up went down. Things that were supposed to not work, worked. The people who needed to support that device understood that there was nothing in the literature that made any sense around what they were seeing. And they brought this jewel of an open question to a university and said, why does this work? And so we did a very fundamental study that pointed to mechanism, ultimately about how to control stresses at fluid interfaces. And it opened up new paradigms for research. So we can define partnerships that matter and that are appropriate. And so I'm fortunate to be at University of Pennsylvania, where we have this it's this very broad university. And so parts of the university are already doing this, and they're doing this really in a large scale and quite well. And so I'm going to open with some of those examples, and then I'm going to shift to what's going on in my school, the School of Engineering and Applied Sciences, where really we're starting to build these things forward from a much earlier stage. We're still in nascent stages. Okay. So this is a slide from my friend and colleague in the Perelman School of Medicine, Glenn Galton, and it's about the partnership with Novartis that they have. They have an alliance with Novartis, which is a very large-scale operation. And they're able to achieve this within the university structure. And so this means that they needed to have extensive discussions ahead of time about how to handle a truly collaborative effort to truly impact some space. So I'm not going to go through any of the details, but simply to say these partnerships can exist. And so the main point here is to make T-cell immunotherapies. And what Glenn has done is he's actually, and I'm not going to spend most of those slides with him, this is just the one, is that he's done it's not a postmortem because it's a still alive, beautiful thing. But he'd done a postmortem on a series of alliances that they'd had previously and what's going on now. And what made this work and what are the things that they've learned about setting up partnerships that are distinct from what they were doing earlier that didn't succeed as well. And one of the main issues that they've seen is that they need to really have identified aims that are tied to goals of mutual interest. And so in the case of this collaboration, getting this new class of immunotherapies developed and implemented is a major goal for both parties. And then there's been a lot of discussion ahead of time about how do we plan how to do these problems? How do we plan about how we're going, what information is or is not shared? How do we plan to really implement new ideas together? And so this was just a motivating slide. I envy the numbers and the scale. And in my school, we're starting to, at much earlier stages, in developing these relationships. So one key point, though, is that we now have an environment in terms of IP and tech transfer, et cetera, where we can craft structures that work. Okay, so the School of Engineering. So we're at about 120 faculty, and we have a very diverse funding portfolio. But if we look, about 10% of it is from corporations. And then if we do really delve into that, many of those are subcontracts, where, for example, people in our robotics or embedded systems groups have written collaboratively with industrial concerns to get grants from the government and then are working in some contract ways. So that's one way of collaborating, but there's this other way, which is truly defining joint goals and reaching into sponsored research agreements, which is less developed. And that's been one of our goals is, can we set up structures, number one, that will allow contracts to move forward under terms that will be acceptable to both parties in a finite amount of time, so that we can innovate together before what we wanted to innovate on is obsolete. Because not all institutions move quickly. Another concept was that these dollars are more valuable than dollars, that these are relationships and that these are intellectual pools of expertise, that if we can find a way to work together, that there are significant benefits that we can gain. So it's really beyond the dollar value or the protection of the IP. And so in that regard, we've had a major restructuring recently. So I was very lucky, actually, in that I took this job and saw this as something that we should be working on in the School of Engineering and Applied Sciences. And it coincided exactly with the timing that we were completely reworking our Center for Tech Transfer to become the Penn Center for Innovation. And so there was a chance to share ideas about what we thought would be more effective. And so we've just launched this Penn Center for Innovation. And one of the major pieces of dialogue that we've had is that not all IP is the same. That a blockbuster drug is something that you might protect very differently than a piece of an iPhone that's going to be evolving on a much faster time scale. And that not all relationships are mostly about the IP. And so that was already a major discussion to have in a university setting, where we're naturally conservative institutions. The other concept was that could we create, and apparently we didn't, the word on the street was not always that we were the most cooperative. And there's been this dialogue about the idea that companies often want access to the work that they sponsor. And so the question is, how can we create structures within the context that Penn owns the IP? Can we pre-negotiate licensing terms, et cetera? And so this has been a major cultural shift within the institution, where we recognize that, you know, an embedded chip is different from a blockbuster drug, is different from an innovation in making smart coatings, okay, and soft matter, biomedicine, et cetera. So each thing has to be treated contextually. Another major shift, frankly, is in relationship building, to thinking about how the value goes beyond dollars and IP. In my case, for my PhD, the value of that intellectual discussion that pointed to a gap in our knowledge that mattered was a gift. It was a gift, that discussion, that we don't understand this and that there's nothing in the literature that addresses this problem. This is every PhD student's dream, to be told, do this and it will matter. We can also create, and so what matters? So together, I think, we can actually go after things within, and in hybrid schemes also, with sponsored research agreements, with government funding, with foundational funding, looking and saying what matters to society. Can we address issues associated with water or energy or cybersecurity, et cetera? Because very often that partnership, if we can build trusts and partnerships, we could be more effective. So the final thing I would say is that it's wonderful for students to be able to interact with people who are in practice. And so creating and nurturing those ties, they all come together. When you start to speak to somebody about whether or not there would be some interest in understanding the research expertise in your school, they immediately ask you, what else is going on in your school? And so there's a chance to build out liaison for your students, your graduate students, your postdocs, your faculty, et cetera. So you can really, it's a very broad brush, and it's not just the dollars. So we've been working on this. We've been working very diligently, in fact, and we are about to announce, this is quite an informal setting, I'm hoping, that we have master research agreements with major corporations. And so Lou Graziano is here, who's worked with us so wonderfully in setting up our partnership with Dow. We've been working on them with other organizations as well. And the path toward working toward building partnerships is in itself wonderful for students and young faculty. You set up workshops and symposia and various structures for intellectuals to meet intellectuals. So one of the points that I should have noted in my colleague Glenn Galton's what works and what doesn't list is that what doesn't work is if you have the chief scientific officer say, I graduated from the school, go collaborate with them. So if you don't really have sustained interest in each other's output, there are no free dollars waiting in industry to give to academics. They aren't extra dollars. And there's no sort of ability just to do throwaway cash. If you don't have real partnerships truly identifying problems where they can exert themselves, then things won't progress and they won't be sustained. Okay. So we can do these things at all levels. Here's just a vignette of something called the X Lab, which is an immersive design and technology lab. It's about the living room that would be, is he Simon? It would be his dream. It's a completely immersive experience of working with the Internet of Things in an entertainment space. And we have this space opening at Penn with the support of corporations for students in design and in engineering and faculty in design and engineering to innovate in this concept space. And so that's fun for the students, okay? And innovation space for the faculty involved. We've also been building partnerships out based upon areas of strength at Penn. So one example is that we have this research, the center called the MERSEC, which is the Laboratory for Research on the Structure of Matter. And so we've done two things that are just examples of bridge building. One of them is, for example, we recently had, I run some part of that, and we had a Penn Day at Gore, where some group, some cohort of faculty and students that work on a certain area that's of tremendous interest within Gore spent a day in a symposium that we held in residence there. Wonderful. The students came out talking about innovation in a completely different way. And then we have a model that I think would just be so exciting to follow, which is Solvay, which has had a long-running support at the University of Pennsylvania with embedded postdocs in UPenn labs. They're supported both by Solvay and by a CNRS grant, and this is now a relationship that goes back to 2007 and is really generating science at the leading edge of the discipline. So with that, I'll conclude. The final way for us to begin to engage, I think, is if we think about facilities. Universities have brilliant facilities because they have the researchers that use them. So if there are tools on the campus that the corporations need, there are very often experts on the campus that they would also need. So with that, I'll conclude. That's my view in about where we can grow and what we can do.
Is there a question that meets my criterion? I know that's a little intimidating, but yes. Take the mic.
Hello? You have a lot of intellectual energy. That was very impressive. So my question is, we talk a lot about kind of science professionals and stuff in this really innovative space and these collaborations and stuff like that. And I was wondering if you care to say more about where the humanities could be useful in this, since you talk about comprehensive university and a lot of different expertise are coming to bear.
That's a wonderful question. So I think it's a really interesting question, and because I've been remiss, partly because I am a dean in an engineering school, not in a deputy dean in an engineering school, not in the arts and sciences. But I think the manner in which organizations work and how partnerships really work effectively, and what are you really after, could be so honed by people who are. That's more of a social science answer. But the dynamics of a human enterprise and how we work effectively within those dynamics, I think that there could be tremendous contributions, both in sort of managing of upfront expectations and all the way through. I think that so in that sense, I can see tremendous roles. If I think more towards sort of the more pure humanities, I'm more challenged to think of it. But I think it's a wonderful question. Yeah.
Well, it's a pleasure to be here with you. How do I go forward? So I'd like to begin by giving you a little bit of background about who I am and why the opinion that I'm going to give you might have some validity. My message is actually quite different from Kate's. I think that we have a pendulum that swings that dictates how industry and academia interact. I've been a professor for over 35 years. I was a department chair for 12 years. I was the vice dean for research in the School of Engineering for a dozen years. I've had numerous grants and contracts from the government, over $30 million worth over my career, the largest of which was over $25 million. I've had numerous research grants from chemical companies, including DuPont, Union Carbide, Kodak, and Exxon, as well as a number of small companies. I spent considerable time consulting for the chemical industry. I've consulted for over 25 companies. You may not know it, but academics generally are restricted to consulting no more than 50 days a year. But over the first 10 years of my academic career, I consulted over 480 days with industry. So I was up against that 50-day-a-year limit almost every year. I've had years where I made more than twice my academic salary in consulting income. I've had consulting relationships that have been 1 or 2 days, and I've had some that have lasted several years. I've had 3 that have lasted over 5 years. They're with Union Carbide, Kodak, and Grace. And my relationship with Union Carbide actually lasted for over 12 years. So I've spent a lot of time consulting. I spent 2 years as a group leader. While I was teaching full-time, I spent 2 years as a group leader in a chemical company and would go visit every 2 weeks and meet with all the members of the research group and sort of discuss what they had been doing and what they should be doing the next 2 weeks. I had my own office in a different chemical company for over 3 years and consulted there regularly. I've been on the board of the Council for Chemical Research for 21 years, and I'm currently the past chair. And I mentioned CCR because its purpose is to promote collaborations between and among the chemical industry, universities, and the national labs. And the organization is dedicated to that, and I've been an active part of that organization for 30 years and been on the board for 21 of those years. This is what I think of the current state of industry and university partnerships. It's in the toilet. It doesn't mean things aren't getting better. I think we've passed the nadir, but the things are still not good. Let me explain a little bit. I joined the faculty of Hopkins in 1979, and the attitude at JHU at that time towards corporate-sponsored research was unfavorable. I can remember the first faculty meeting, the first engineering school faculty meeting I attended. I was a brand new assistant professor, and the topic of discussion at that meeting was industry-university collaborations and consulting. And the meeting, several people spoke and expressed concern that corporate money might taint the academic environment and probably wasn't a good idea. But I remember very clearly that the conversation sort of ended abruptly when a chaired full professor stood up and said, "If industry dropped a bag of money at my feet, I wouldn't bend over and pick it up." So there was a fairly hostile attitude towards corporate-funded research, at least at Johns Hopkins at that time. I think Johns Hopkins was an outlier, but I think that attitude was prevalent in a lot of U.S. universities at that time. I became a representative of CCR, the Council for Chemical Research, in 1984, and in the mid to late 1980s, corporate funding of chemical engineering departments in the U.S. averaged 45% of the total research funding. And by the mid to late 80s, corporate funding in chemical engineering at Johns Hopkins was over 40%. And so we were almost at the national average. But I remember those numbers very clearly because it was stunning to me how much things had changed at Johns Hopkins in less than 10 years. And I had thought we were an outlier, that we had this huge amount of corporate funding. 40% was to me a great deal of corporate funding, but we were actually below the national average. And so where are we now? Today at Johns Hopkins, Hopkins has a total research budget of $1.6 million. The federal research budget is $1.3 million, and the corporate research budget is $55 million. That's 3.4% for the university as a whole. And you might say, well, Hopkins is predominantly medicine, and they're not going to have a lot of corporate funding. But actually, the majority of that 55 million that is in the university, the majority of it is in the School of Medicine, and they're actually at 6%. And they're what brings corporate funding at Hopkins up, not down. Engineering at Hopkins, we have $72 million in funding. 67 of that is federal. Corporate is 1.3 million, which is 1.7%. Arts and sciences is 0.3%. Chemical engineering, we have an annual research budget of just over 11 million, and only 100,000 of that is corporate. That's 1%. Our Department of Chemistry actually has slightly better, with 1.7%. But all these numbers are a far cry from the 45% that existed in the late 1980s. And so why has this happened? Why have universities and corporations drifted so far apart? On the university side, I think there are two things that come into play. One is the Bayh-Dole Act. And prior to the Bayh-Dole Act, for those of you that don't know, defines how universities are allowed to deal with IP, intellectual property, that is generated with federal grants and contracts. Before the Bayh-Dole Act, if a university faculty member invented something while working on a government grant, that intellectual property got transferred to the government, and the government agency that funded it decided whether it was going to be patented or not. And the answer in almost all cases was not. And so prior to the Bayh-Dole Act, very little in universities was ever patented. Now, the university could petition the government if the government decided not to patent. The university could petition to have that IP returned, and if it did so, the university could patent it. But that was fairly rare, both because universities really weren't interested in patenting, and because the government agencies very seldom said, yes, you can have the IP back. So what happened with the Bayh-Dole Act in the 1980s was that the Bayh-Dole Act said to the universities, if you invent something, you can keep it. You can profit from that invention if you decide you want to patent it. And all universities set up IP policies. Those IP policies are different from university to university for several reasons, but the predominant difference is because state universities, their IP policies are dictated generally either by the state legislature or by the university's board of trustees. Private universities are different in that, yes, the board of trustees can have some say in the IP policies, but many of the IP policies present in private universities are not dictated by the board of trustees. They're dictated by the IRS. Private universities are all nonprofit organizations, and as such, they have to adhere to very strict rules about how they interact with for-profit entities, how much money they can take in per year from for-profit subsidiaries, and so on. And one of the rules that the IRS says is that, regarding IP, is that private universities are not allowed to pre-negotiate the value of intellectual property that has not yet been created. So if we enter into an agreement with a company, and the company says, if you invent something, we'll give you X number of dollars, or we will give you a royalty rate of Y%, that's illegal. And the reason is that you're valuing the intellectual property before you know what it is. And if you're valuing it before you know what it is, you as a university, may be using your nonprofit status to benefit a for-profit organization. And so private universities are really hampered quite severely in their ability to pre-negotiate terms and conditions about intellectual property. The second reason is because in chemistry and chemical engineering departments around the country, universities have really put a huge emphasis in the areas of nanotechnology and biotechnology. And the reality is that most to the chemical industry. On the flip side of this, on the corporate side, there has been a dramatic reduction in the corporate emphasis on fundamental research at corporate labs. This began in the 1980s, about the time of the Reagan administration. At that time, Exxon opened and then almost closed its corporate research facilities in Clinton, New Jersey. Mobil closed up its shop. DuPont severely shrank the research efforts at the experimental station, the fundamental research that was going on. And in 1989, I was at a Council for Chemical Research meeting, a chemical engineering department heads session at the Council for Chemical Research. And one of the topics for discussion was the opportunities that are going to arise for universities to work more closely with corporations now that their research labs are scaling back. And everybody was saying, boy, this is going to be great. We're going to, companies are going to have to do research. If they're scaling back their corporate labs, they're going to have to come to us. And everybody was happy and excited about this potential new opportunity. And Bob Brown, who is now the president of Boston University, but who at that time was department chair of chemical engineering at MIT, later became dean and provost at MIT, before becoming president at BU. Bob Brown got up and said, get real, guys. As corporate research labs scale back, as they lose their fundamental emphasis on research, what you'll find is that there's nobody left in industry that you can even talk to. And in fact, I did a lot of consulting, a lot of work in the chemical industry in the 1990s, and as time progressed, that's exactly what happened. There were fewer and fewer people that could understand what I was saying. So I think that things are even worse today than they were then. Companies now are looking to create strategic partnerships with universities, and I think that's a great thing. But we're coming out of what I think is a very deep hole. And one of the issues that makes it even more difficult to get out of that hole is the insistence of many companies on owning IP. And as Kate mentioned, and as I said, private universities are almost forbidden from being too friendly with corporations in terms of IP. And with that, I thank you for your attention.
Question? You're keeping your powder dry? All right.
How do you,
Peter, take the mic.
My time is up.
having been in the chemical industry all my life, and I know very much about what happened in the early 1980s, companies like Dow and many others who cut back tremendously in their research. But I'm wondering, we still, in the US, issue as many patents as almost any other country in the world. How does that relate to the complete cutback of corporate research that you describe?
I'm not familiar with the patent statistics, but one of the things that you have to look at is that Yes, the number of patents is actually gone up slightly, but the number of patents issued to US corporations, except for a few, IBM still patents a great deal, General Electric, I think, still patents a great deal. But I think if you looked at the patents from companies like DuPont and Dow, they would be down substantially from what they were 20 years ago.
Thanks, Mark. Just as a point of information, about 2 years ago, the number of patents issued to China for the first time eclipsed the number of that are issued to the United States in chemistry. I don't know about all fields, but the gap will continue to widen.
Speak into the mic, please.
Thank you, David. Thank you.
Well, it's a pleasure to contribute to the panel discussion, and actually I'm going to take you in a different direction because I'm actually putting both hats, the industrial and the academic hat, giving my experience. And I try to promote academic-industrial partnership over the last 5 years, and I think we've been successful in doing so. So what I'm... Did this my slides here? Are we going to switch? And then you can forward from right. Right. So what actually I thought I'll do today, as you can see on this, okay, thank you. I will touch base on what's available for academic, and my background is biomedical research, particularly on drug discovery, and then we'll talk about that really in order to work with industry, you have to make sure that your innovation is protected and you have already a patent on your innovation. And then, of course, now you're dealing with another partner from the outside, you need a negotiator. And one of the things I tell you by and large, and I hear from Hopkins, from Penn, and I've been giving lectures around the country since I joined the academia, the weakest link in academia and in most universities, including the Ivy League, are their tech transfer. And this is where most of the collaboration collapsed. And I have to make major changes when I joined Temple University. So we talk about something, a little bit about the tech transfer, and then I'll talk about what's available for funding for academicians. For biomedical research, our major partner is going to be a pharmaceutical company. And as we all know, and we heard the decline from DuPont and other pharmaceutical companies, the same thing, they're actually going through challenges in the last 10, 15 years, losing patents. There is no new drugs coming. The most drug approved every year, no more than 20 to 25 drugs, except in the year 1996, where 56 drugs were approved. So that shows you the gap, how pharma is really struggling. So what they try to find a solution that maybe we should increase our partnership. And that's where really academic can come in, but not just academic, because they can partner with biotech, with actually other private, small spin-off company, and so on. So they want to do a partnership. Unlike in the old days, pharmaceutical company have to do everything in-house. And that's what I refer to as NIH syndrome. Not invented here, we're not interested. So they abandon this because they can actually diversify risk and they can get more actually ideas from the outside. So what they're looking for, they're looking for three partners, either with biotech, with academic, or as we mentioned here, the contract research. So what they're looking for, every partnership is different. They're looking for things to go into to make a drug for them, or they're looking for people to do the work, increase capacity, where they headed to China and India because many of the researchers there are educated in the US and Europe, or they come to academic for innovation because pharma is a business. They are not going to work in disease if you don't have large patients. They only work in disease affect US, Western Europe, then the rest of the world. So, but academic, we have academic freedom. We work in any disease. So they look actually with academic to come up with ideas, to turn them into drugs, to work with them. And this is where important for us to understand how we're going to collaborate with them. They abandon the old days where they throw money at you because they want your graduate students. They want access. And now they actually go for true collaboration, shared risk, shared reward. Sometimes even shared expenses. If I work with them and it costs that much, I pay 50, they pay 50, but the reward is 50-50. And I managed to do that in the last 5 years. So we need actually to have negotiator. And that's where the tech transfer, you have to have people who have right skills, because you're dealing with science and also you're dealing here with innovation and patent, but more important, negotiation. And that's where the tech transfer offices is going to be crucial, because they overvalue. If I have a professor have an idea, and I dealt with a few of them at Temple Medical School, they think they have the best thing since sliced bread, and it could be worthless. So the tech transfer will put high value, then they will never collaborate. So it's really very important that they in terms of negotiation. More importantly, patent. Universities are not known for patenting. So it's very important that you understand what kind of patent you're going to do. And for our work, it's mainly utility patent, where you patent molecules or uses in order to make them value. And that's where the tech transfer have to understand doing this. I just heard from my colleagues in Hopkins about the patent policy. All the universities have patent policy, but it's different what they do with invention. So I've been privileged to work with Temple as a postdoc, and I know the patent policy then, where 50% goes to the university, 50% goes to the inventor. Now actually there is clarity, and it's 40% goes to the inventor and 60% goes to the university. And the university proceed, they have their own way, give the school a little bit or give the so on so, but the inventor get major portion. I remember working with Professor Daniel Swern, and we got 50-50, and that was patent during my postdoc. So you need to have the clarity, and you need the understanding of your invention and the strength of your IP to do this. When I went from industry to academic, I used to have a department with budget 120 million a year, and I came to school where their entire budget is 6 or 7 million a year. So this means I have to raise money for research. So there are a lot of available ways to do that. We heard from Tom and my colleagues, the federal government, whether you work with NIH, NSF, or Department of Defense, they actually have supported basic research and also applied research. But we found also in Philadelphia, we have a unique non-profit organization offering money. And I'm talking about the Science Center and the Biostrategy Partner. And I was the benefactor, my group, of getting a lot of funding from them. And they actually join the industry, bring them to you, where you talk about mutual interest between both of you, and they offer some funding for academicians. Of course, the tech transfer department at Temple, now they have some funds where they can offer some money up to 100,000, where you can conduct your research with some support from the outside. So these are some of the available ways, of course, in addition to the donation and others and so on. So there are a lot of opportunity for academic to be entrepreneurial. You take the federal funding, you create an invention, you have a patent because you're allowed to, and then you can partner with industry. In the meantime, you can have also venture capital, and you can spin off a company in academia, and you can work on that premise. Let me close in 3 slides just to show you what we've done in the 5 years. As I said, with the industry going down in pharma, a lot of universities start establishing drug discovery. And I mentioned few here, and you have to keep in mind that university brag that they do drug discovery. And I know my colleagues in Hopkins, they have drug discovery, although 3 of their famous professors working with us. And the reason I'm saying that, because many were called and few were chosen. In order to be successful drug discovery, there are some requirements, and I list them here. It's very important you have the university support. And the university support comes in the fact that when I said I'm going to build drug discovery at Temple, but I need to hire tenure track faculty. I went into argument, but I won the argument, and we have 6 or 7 tenure track faculty in the drug discovery, plus staff also from pharma and experienced. One thing we did different from others, the founder established what the center will do. It's mainly the all biology. I'm a medicinal chemist, so we have a strength in medicinal chemistry. And that's what we established at Temple University, and we were able to do drug discovery at all phases. And we established all the function needed. And based on that, how I'm going to support the non-tenure track faculty and the staff. So my business model is flexible. And those who live in Philadelphia remember the old days there was ad in TV for Earl Scheib will say, I'll paint any car, any color for $29.99. I do the same in the drug discovery. We'll do any work, research or contract. And I convinced the university that we can do the research, academic mission, grants. We can also do contract research, and that was a major funding for us. And you know what? Pharma do outsourcing, I do insourcing. Those companies in China and India, I can help them to run their projects better by offering them project management if they support my staff. And that actually worked well for us. We have well-integrated center. In the last 5 years, we started with $500,000, and this was for me to come in and establish. And then we were able to get $8 million from the university. We were able to get $7.5 million from the federal grant contract research. And just last week, one of the alumni endowed $5 million to the center. So we actually realized that partnership go beyond the federal government to support research, and then you go to industry and you can expand and can generate IP for your center. And I was pleased to hear from Temple that the IP filed this year, 50% came from the Drug Discovery Center. So you need the IP, and so you have a commodity, you need good negotiator, and then you need to do partnership, whether contract research or joint risk, joint reward. Thank you very much.
In order to keep this symmetric, we'll do one question for Megid, and before I start to cross-examine them all. Yeah.
Yeah, I'd just like to offer, it's more of a comment than a question. For a number of years, I ran the technology transfer office at Rice University. And so I want to address my remarks to the negotiations that take place between the university and companies. And rather than get specific about details, it's a difficult negotiation. But I'd like to point out that the difference in character of the two sides of the table. Businesses know how to negotiate with other businesses. They're for-profit businesses. They know how to negotiate with each other. They have an experience on how to do that. Their lawyers know how to do that. Universities and a tech transfer office are running a for-profit business within a nonprofit, highly conservative operation. And so the rules and regulations, as some of you have pointed out, are entirely different within the university. So the two sides who are trying to negotiate are coming to the negotiation from an entirely different points of view, and starting to negotiate with a new company that university has not negotiated with before can be extremely difficult, painstaking, and take a long time to try to cut through and get a deal done.
I think my response to the comment, I'm sorry. I just want to tell you that when I did the first contract research, I did it with a Swedish company. It was $2 million for 2 years. That contract research took 6 months to get it signed with the tech transfer. I met with the chief counsel and I sat with him and I said, I don't understand, because I used to run a few things like this in industry. So we reached an agreement. When you sign confidentiality agreement or material transfer and all this, I said, what the university's template? And he looked at me and said, what do you mean by template? I said, well, we want to agree together that we're going to have a template, and then I use that template and send it to my partner. And then I get from there their correction, and then you look at it and your attorney. Believe me, we do that, and we can get it signed within 48 hours to 3 days. So there are some creative things you can do, and I know as you mentioned, because there is profit and non-profit, and they get stuck in the middle. And also when they talk to the scientists, they overvalue. I mean, I have people want to collaborate with me, and I get in the middle of the night email, copying the deans and all this, say that this is my area of interest, and I can get chemists to work, and so we owns everything. It was in the medical school. And I just sent simple note to him. I said, I would suggest that you have your enzyme, you put it in a bottle, and you go sell it. See what you can get for it. Because when you work with me, I'll give you a drug candidate. And that's the thing, when he go and collaborate, and then the tech transfer will put high price, high value, and this will stall the partnership. So that's what I meant in terms, there is so many things in negotiation. And I was glad that the tech transfer now involved my team in these negotiations. It's been working very well.
So let me start with the three of you by defining a somewhat artificial continuum, and I'll turn it into a question. So on one end, you have military research. The largest percentage of R&D in the country is military. It's about 60% of the total that the nation spends on R&D. It's secret, a lot of it is secret, a lot of it is classified, and none of us can find out what it is or if it's good. So that's one end. The other end of the continuum is what we could call the traditional university model. It's driven purely by the curiosity of an individual investigator. There's no commercial consideration at all in what they do, and everything's public. So the question is, where do we want to end up? Neither one of those is viable for a university anymore. Where do we want to end up in the continuum at the end? Somewhere close to where universities traditionally were, or are we willing to slide a long way towards the more secret side? I'll address that to any of you who wants to take it.
So Johns Hopkins has, as I mentioned, $1.6 billion a year in research. Of that, about 50% is military. And of the approximately 800 million that's military research, probably 600 million of it is classified. Not all of it is, though. Some of it's not classified. And 600 and probably 200 million, the dollar amounts and the funding agencies are even classified. You can't find them in the congressional record. You can't find them in the national budget.
I'm not making a judgment on that. I'm trying to figure out where we want to be on that continuum.
So Johns Hopkins tries to be across the entire spectrum. We're the largest recipient of federal funds for the military, and we're also the largest recipient of federal funds from NIH. So we're trying to cover that entire spectrum. We're not the highest at NSF, but.
I'm guessing you want to take a different point of view.
Yeah, so first off, I should note that I have a tie to this man who hired me as an assistant professor into Johns Hopkins University, which is where I grew up in academics. And you have a special situation with the Applied Physics Lab. So there's a separate campus at which most of this takes place, which is not part of the sort of normal university story. It's a special story. Mm-hmm. So at Penn, we do work that we're going to publish. So we're very, very dedicated to that idea that we are not a place for top secret work, which you have a distinct and very different structure. And so our flag is firmly planted that our job is new knowledge. And so, so work can be protected, we can have IP, we can have agreements, but we will publish. So we have a very strong mission as a university to be a place for new knowledge, and a very strong part of our identity is defined around that stance.
Megan, did you want to say something?
Well, as I said, I mean, that comes under the philosophy of the Earl Scheib philosophy. We'll do the Department of Defense, and we'll do that as a contract research, which currently I'm doing one, actually, for almost $1 million for the next 5 years. And that's like fee for service, which is fine with me. But we also have to distinguish, as Katie mentioned, that the work which you give your graduate students, so really the publication is an obligation. And then that's why I try to patents very early on for things, and then so we can get it followed by publication too. So we believe in that, in academic mission publishing.
So let me make it more concrete than that hypothetical question. Every university industry alliance that I've seen gives the sponsoring industry the right of first refusal on any invention that comes out of the research. And that makes perfect sense, because why else would they do it? They don't have to take it, but that's why they do it. And what the university gives in return is usually some kind of delay on publication so that you don't void the right to do a patent. So part A of the question is, what publication limits are you willing to accept at your 3 institutions? And then part B, and related to some of the things that you mentioned earlier, and that you just alluded to, Megan, a lot of the work in research labs and universities is done by grad students and postdocs. In your agreements with companies, what rights do they have on the ensuing intellectual property, and how are they harmed as needing to publish or create dissertations out of the results? So there's several things embedded in there. And you can
well, in terms of, let's talk about publication. So some partnership, they will try to delay it. And I try to push for, since we give them the notice or the draft, I start with 30 days. And of course, they all refuse that. So we go between 30 to 90 days, then we are free to publish. And then if you have upfront agreements on talking about intellectual property, this is coming, has to be, that's why the first agreement you take with them is the most important one. Like when I did for this Swedish company, small biotech company, and it was like contract research, but we built in that agreement that they own all the intellectual property. And we get in return milestone if it goes for clinical trial, and we put their milestone. So we filed 5 patents. They own them. And that's how I convinced the tech transfer and the university. I said, guys, if this is what they want, and that's what we're going to do, let's agree that up front. I look at it as cash and carry deal. And I'm going to get you the overhead. Because every university have this overhead, 56 or 70%. So I calculate for this company, this is what I'm going to get, plus multiply by 56%, hand it to the university, everything worked fine.
So Hopkins' policy on publication delay is that we generally begin by offering 60 days, but University Board of Trustees policies say that we cannot accept more than 90-day delay. We give companies not just first right of refusal on any intellectual property. Our stand is that we will negotiate in good faith based on the value of any invention. And you can actually be sued if you don't negotiate in good faith. And the university's position is that should be adequate, and that satisfies the IRS regulations. But Johns Hopkins requires that we retain ownership of the IP, and that any license that we give has a due diligence clause to practice, because the university believes that our purpose in creating intellectual property is to benefit society, and so we do not allow a company to license an invention and then just sit on it if they have a competing product in-house already or something like that. So they must have due diligence in bringing the product to market, and if they don't If they don't pursue that due diligence, then we withdraw the license. We demand that the license to the property be, the intellectual property be returned to the university so that we can license it to someone else.
Okay, so the point that I wanted to address was how to fairly handle doctoral students and postdocs. And the university, our stance is that anything developed in the labs is the property of the University of Pennsylvania. The IP belongs to Penn. But inventors, via a return of any dollars generated from that IP, the inventors can be recognized, and so they can appear as co-inventors. We have some limit to how long a delay will accept, and I'm sorry, I don't recall those details. But the biggest story is that they can appear as co-inventors on work if they've done something that was actually helping to invent. So, and therefore participate in the return of funds, et cetera. So I don't think it's an egregious, as I said, I did fundamental work. It didn't lead to IP. It was also much more naive time as to whether or not it could have led to IP. But certainly my career was strongly bolstered by my interactions with industry as a doctoral student in understanding that people really cared about the outcomes of these kinds of analyses and discussions. So I think we can still hold the graduate student and postdoctoral mission dear, of training them in an intellectually rich environment that's not at all punitive or unfair. Yeah.
I'm going to ask one more, and then I'm going to turn it over to you all, so start thinking about what you might want to find out. But it sounds to me like all three of your institutions, as I would expect for major research universities, have pretty well-established technology transfer policies that are clearly spelled out and that you adhere to. And that's progress compared to the way it was in some of the places not very long ago. The subject of technology transfer is a very complicated one. We have, I didn't know, but we have a working, former at least, working professional from a big research university. And I'm sure none of you except you have seen it. The American University Technology, it's a professional group for people who do technology. Autumn, right. That one, right. They have like a 6-volume set of manuals. It's about this thick on a shelf for how to do technology transfer. So it gets to be a pretty arcane and difficult and complicated subject, as you alluded to. But I have always taken a really naive approach to it, and I was reminded of it by something the two of you said, and that was the best way to get technology transfer was simply to take a university of research scientist and put them in an industry lab for a period of time. And the reverse, take industry scientists, put them in university labs, and let them rub shoulders with each other. That's how you generate the frisson and kinds of intellectual activity that leads to reduction to practice and commercialization. And I heard Kate say that they had a really successful example of that with Gore, where they brought Penn people to Gore. I guess you went there. And I heard Mark say that there isn't anybody left anymore that he can talk to. So I want to know which one of them, which is right, or are they both right?
I was talking to a lovely group of researchers who were highly interested in the work we were doing. So, I can't refute Mark's numbers and the trends that took place and the consolidation and contraction of R&D that occurred. But I think that there certainly is a community of people with whom we can engage. We have 2 examples. So the workshop with Gore was really it was a relatively small, in fact, highly successful day where the students and postdocs were interacting with these researchers within the company. But we also have this model which has been going on now since 2007 with our interactions with Solvay, which started years ago while it was still, I think, Ron Poulenc or Rodia. And so this is a long-standing collaboration, and there are postdocs embedded in Penn labs who work on fundamental areas that are of tremendous interest to Solvay. So there are models that can work. I don't know as much about researchers going into corporate labs. I think that the environment there might be tougher. It might be something someone can do on a sabbatical, for example, but I don't see it as a sort of daily existence thing unless you did it on a consultant basis, as Mark has talked about in his experience. But
Yeah, let me just say, I spent a summer in a company, and then following on that, consulted sort of irregularly for them for a couple of years, 3 or 4 or 5 days a year for a couple of years, and then started consulting more heavily and ended up taking over a research group and ran an internal research group within the company for 2 years. And then for a few years after that, consulted, again, sort of on a sporadic basis. In another case, I spent another summer at a company. Actually, it was 4 days a week, not 5, but 4 days a week in the company. And for 3 years after that, I spent a day a week, every week at the company. As mentioned, I had my own office in the company. And I agree completely. In both cases, the opportunities for collaboration, interaction, and building something that really is mutually beneficial was greatly enhanced by the fact that I'd had an opportunity to spend time in their environment for, you know, a protracted amount of time, not just a day or 2 here and there.
I'll take that as a both models work answer. All right, so who's got some things they want to address? And please identify yourself and speak into the mic when it's brought to you.
Thanks, everyone. There are a million top things I was jotting down as we were going, but I'm not going to try to talk about all those. I'm Lou Graziano. I'm with Dow Chemical Company, and I would like to just follow up a little bit, Mark, on your comments, because I think there are some nuances around that IRS, and I'm a little hesitant to talk about this because I'm not an expert in the area, but I think those nuances are not that you cannot pre-value IP at all, but aren't they tied into related to use of facilities that have been funded through a tax-free bond and a threshold? And the reason I bring that up, the reason I bring that up is there are a lot of universities that have found ways to do that and have had a lot of discussions about, you know, with their general counsel about the opinions about what can work and what can't work. So I think it's not quite as black and white as you might have presented, or else maybe a lot of universities going to get pulled up to the IRS. I don't know, but so I think there's more to it to that, and what I'm getting at is that does represent a barrier for collaboration. And I think what we all want to try to achieve here is we got a lot of great facilities, capabilities, and minds on both sides, and we want to find ways of getting over those barriers that allow us to make use of everything we have and get the leverage of those capabilities together.
I agree completely that the goal is to get over those barriers. It's my understanding that the tax-free bond issue is a separate issue from the pre-valuing of IP, that they're not that there is an issue with tax-free bonds, but it's a separate issue of pre-valuing IP. Our university, perhaps because we're the largest research university in the country, is extremely conservative in maintaining our relationship with the federal government, with the IRS, and with the federal, maintaining our tax-free status and our overhead flow and all of those things, because we're so close to Washington. If the government decides they want to audit somebody, they always come to us first. And we had a period several years ago where we had, I think, over 100 IRS auditors on campus for over a year, going over our books. And so our general counsel is extremely sensitive to these kinds of issues and has indicated that we just aren't going to take a chance. I know Dow has a relationship with Northwestern, which is a private school that has the same kind of issues that we do, and I know you've been able to overcome it with them. And I have discussed the Northwestern arrangement with Dow, specifically with our general counsel, and our general counsel said, we will not go there.
And I understand that. And so my point is that it comes down to, I mean, just like when I go to a lawyer in our company about doing something and they say no because they don't want to take the risk. So it really comes down to risk tolerance because we don't go to our partners and say, hey, ignore the IRS, do it our way, you know. But I do ask our partners, okay, so how did you, because, well, you and I have both been on CCR together. We've been in parts of a lot of these discussions. How did you manage your way through these things? So we don't try to get them to do it, but there are quite a few partners, some of them private, who have said, yeah, we've agreed that we can do this, and they have also told me it involves a lot of tracking on their part and things like that. So it comes down to risk tolerance, and I guess that's that way with almost any law, right? How you interpret things. So I think you can find ways to get through barriers, and I'm really impressed to hear some of your experiences of how you've managed to streamline your way through getting through barriers to collaboration to make them happen. They're great.
I think also, I mean, I want to tell you from my experience, and I work also with academic collaborator, and I have few from Johns Hopkins. I found to be the most difficult people to deal with in tech transfer are the Johns Hopkins people. And no, I'm telling you the truth. I tell you the truth. I tell you the truth. And but anyway, talking about valuing an IP, I mean, and of course I see the dialogue because I've been involved in that, and I think really I really don't have any problem with valuing IP, because the IP, when you file your patent, the most important thing to know if it has a value or not is the university going to follow through on that IP or the patent filing a year after and after with all the cost? Because I can assure you, most of these patents fell by the wayside. So if you really see there is value, I mean, in terms of that could be potential drug, it will be filed PCT, and it would be filed, and that would be a valuable IP, and then we can put some negotiation with our partner saying, look, if you're going to do this, we're going to get this percentage and get this or get this. Or if you want license, and I know some university, as I heard from Penn or others, we can do exclusive license. And that's the thing where we can get the most for our IP. So I think things may be different from one school to another.
Right here is a question.
Catherine Forrest, I'm retired from DuPont. When I was working with, interacting with university groups, I had trouble with management attitudes in corporations. And the two main things were loss of proprietary information, especially even if you sign confidentiality agreements, and also budgetary concerns. If you spent this money, what are you getting for it? How do you interact with those kind of attitudes?
So it's a really excellent question, and I think it's still evolving. That one of the things that's clear is that we don't have a right, even if we have a context of a right to publish, we don't have a right to publish confidential information. And we try to cast things in a light that we really know as little as possible unless it's needed for the project. But I think there's I agree that there have to be, I think the company has to need it. I think these have to be strong mutual goals, or we're not going to succeed. And then the strength has to, the defense comes from the technical need.
It has to work its way down.
Yeah, and this is why also sort of the top-down sprinkling of, fairy dust from a nice CSO who loves the school doesn't take, is that it's got to come down from the trenches of the people who are really solving problems, making an argument within the company that this technical expertise will allow us to move forward in a way that we won't move forward if we don't create these partnerships. But I agree, this is the struggle throughout. Is it a meaningful partnership? Are they really mutual goals? Do we trust each other? And is it needed? Is it addressing a need? But I think, yeah, go ahead. Please.
But then the management attitude, yes, I agree with you, but that's actually depends on some cases, not on, I mean, I've been exposed to that, but the most very important things is the first agreement you sign. And that's why we pay attention to that very much. And I got some attitude from CEO from company doing contract research. And I remember calling him at 3 a.m. and I was in India. And I told him that our contract says so and so, tough luck. I mean, and they actually yielded. So sometime you find that in some individual management attitude. But the contract signed, it has to be really well vetted, and that's important.
I think your points are well taken, but whether you're talking about collaboration interactions between corporate scientists and academic scientists, or whether you're talking about collaborations among academic scientists alone, collaborations among corporate scientists alone, in order to have a good scientific collaboration, no matter what the venue, you have to have mutual trust. If you can't trust your collaborator, you can't trust what they say, that it's really true and that it's right and that it's the best thing that they know, you have nothing. There's no point in collaborating if you can't trust the person. And so I appreciate that corporations have a lot of concern about confidential information, but my sense is if you don't have confidence in the person as a person, that they have the highest integrity in every way, there's no point in even having a conversation. You can't collaborate with somebody that you don't trust.
One thing being at the bench level, is another thing being at the management level.
I mentioned this to someone else earlier when we were talking before the session, but I can't remember the date, but about 25 years ago, when the first really big industry-university collaboration was known, and it was Novartis, the company that you mentioned, that's now working with Penn, they created, I think it was a $40 million collaboration with the University of California at Berkeley. And there was a huge hue and cry all over the campus and all over academia, because how could you do this? It was kind of like I wouldn't bend over to pick up the money reaction. Now, 25 or how many years it is later, you don't get that reaction. And I think it's exactly because of what Mark said. We've built up confidence in each other and in the somewhat different cultures that we have in industry and academia, enough to trust each other that I think that kind of reaction is probably there sometimes, but not nearly what it was even a couple decades ago. And I can't resist saying that in industry, the predominant ethos is dog eat dog. And in academia, it's just the opposite. We're not that different. Yeah, there's a question in the back.
Two fast questions. First, pecunia non olet, meaning money don't smell. Therefore, absolutely, money should be taken if given. However, there should be some institution, some arbiter, who makes sure that academic integrity doesn't suffer. Who should it be? I have no opinion, but I would expect to get it from you. And second, fast question. Professor Donahue mentioned Solvay a lot. In the 20s and 30s, there were Solvay conferences, the phenomenal Solvay conferences where Bohr and Einstein discussed. Since the federal government decided to cut dramatically basic research, wouldn't you expect the industry to take over a bit and do things like Solvay did in the 20s and 30s of the previous century? Basic research in context of the academia industry. Could you address this, please? Thank you.
I'm sorry I didn't get all the points of the question, but this was a big issue back in the 1980s because under Reagan, the federal government substantially cut back its research budgets at a time, and when that first began, most corporate research budgets were still not being cut significantly. But over the next few years, the corporate research budgets started to become eroded as well, predominantly because a change in emphasis on Wall Street from looking at long-term corporate performance to short-term corporate performance. And my sense is that academia suffered on both fronts because of that. I think there was a sense that, in fact, Reagan even came out and said it, that, you know, if the government cuts back, industry will step up. And what happened was just the opposite. As the government cut back, industry stepped back also. And so there were a lot of people in academia, myself included at the beginning, that sort of believed that the line that we were being fed, that this would happen, that as the government cut back, corporations would step up, and just the opposite occurred. And so universities went through a very, very tough time funding research programs at that point in time. You know, and over the last 25 years, you mentioned, Tom, that NIH funding levels used to be at 50 or 60%. You're about the same age as I am, and NSF research funding for young faculty was at 40% when I started teaching, and it was, for all faculty, NSF was about 25%, and we all looked at NIH and envy that their funding rates were so high and NSF's were considerably lower. Today, the NSF funding rates in some programs are under, in most programs are under 10%, some of them they're under 5%. And that's true even for young faculty. So it's becoming harder and harder to maintain research programs in academia. And I don't know how it's going to end up in the long run, but it's a problem.
Well, as he mentioned, that the NIH funding was scarce, and if you recall, when Obama came as a president, what he did, he got what we call stimulus grant, and he gave the NIH, and he said, look, this can enhance research, and they were surprised. I think it was 200 million or so. They received over 25,000 applications for those stimulus grants to do basic research. And basically because funding was really diminishing from the federal government, and not too many industry will support basic research. They're looking for more applied and more getting closer to making commercial product.
Tom.
Can I speak? You just touched on the subject of young faculty. In the statistics you're giving are not very favorable. How do you look at this as going out? All of you are in senior positions. You're hiring young faculty. How do they fund their labs?
I'll tell you from my experience, because we hired about 5 or 6 since I came in, and we're hiring 2 more this year. We try to have some seed money for them to start their research. But the most important for them, when you get a tenure-track faculty, when they apply for tenure, one of the criteria, and I think Penn and Johns Hopkins have the same, is their performance in getting grants. And that's why it's very difficult, unless you really look at the total picture, their scientific output and so and getting grant rewards. But by and large, those young faculty having a tough time getting grants. We give them seed money, and it varies from one university to another. But that's how, when I came in, it was $500,000 to establish the center.
Yeah, it is a very, very tough proposition for many young faculty. I also wanted to put this in the context that the size of graduate student groups and the mean activity of a professor has grown dramatically since I started my career. So somehow we're getting it done. I negotiated for a startup, asking exactly to the dime for what it would take me to build my first experiment. And Mark quadrupled my request, and it's still at 1/10 of the lowest startup you could imagine giving a faculty member nowadays, even corrected for inflation. Okay? So what we give for startups now are packages that allow somebody to actually launch a group. So the universities are investing very seriously into the young faculty. And another change that's occurred, because we have grown, so while we're pointing a very dire story, the average size of a research group in my institution is larger than it would have been 20 years ago. We collaborate much more. So it's a very entrepreneurial faculty in finding ways to find university-appropriate work, fundamental underpinnings, from various funding streams. But the pressure is very high. The pressure is very high. So there are some fields which are in growth modes. There are some who are just young stars and immediately hit. But for many, they push very hard. But this story of this collaboration is also a very interesting thing. I was talking to someone about how creative and collaborative Penn is as an environment, that this atmosphere of collaboration goes back 50 years because we attribute it to, in part, that we had the Materials Research Lab, which then became the MERSEC. And so that's a history of co-advising across disciplines. But it also means that you enter into collaborations when your expertise makes sense, when you can differentiate yourself from your collaborators. And for young faculty, that's particularly important. If they're on a collaborative project where there's someone more senior, that person needs to be a gracious senior person and furthermore needs to be distant enough. But this can all be done. And so there's a lot of collaboration and there's much less parsing of credit, that you can see how did the frog jump by dissecting the frog and then, whatever you do, it doesn't jump. That you can do that also with a collaborative environment. You can parse credit to the point where you spoil it. And so I think, and nevertheless, these people do emerge as people who are intellectual leaders. There is room in these paradigms for this to happen. But so I would say that the way that we run our programs is very different from, for example, when I started in academics. The pressures are immense, and yet nevertheless, I think there's evidence of tremendous growth in the size and the dynamism of the research groups.
So we do several things at Hopkins to help young faculty, but it's entirely correct that if they don't make it, they don't make it. We have a high attrition rate, or higher than we would like it to be. We typically give faculty members, in the School of Engineering, we give faculty members money to buy the equipment that they say that they're going to need to get their laboratory started. We often put in considerable amount of money renovating their laboratories specifically for them. We typically give them 3 to 6 years of graduate student support. Actually, standard package these days, I think, is 2 students a year for 3 years. So this gives them time to get their research program started, and they don't really have to worry about supporting those students on their own until their student's 4th year. So that gives them time to write multiple rounds of proposals. And we typically give them 2 or 3 years of summer salary. It's not uncommon, even for an assistant professor, for that to add up to over $1 million. In some cases, if the lab renovations are really significant, it can add up to $1.5 million, even for an assistant professor. In the School of Medicine, things are a little bit different in that the average age for the first R01 from NIH is the standard sort of independent researcher award. And the average age when people get their first R01 is about 44 years old. And so you have to exist a long time from the time you get your MD or your PhD, which is usually in your late 20s or early 30s, until you're 44. And so how do you exist that long on institutional funds? And it happens 2 ways. One, the startup packages are even bigger in medicine than they are in engineering. Those startup packages start at about $1.5 million, even for an assistant professor, and sometimes go as high as $5 million. But also you have this issue of senior mentors. Nearly all of the assistant professors in the School of Medicine at Johns Hopkins are supported by senior faculty members. So you might have a senior faculty member with a very good reputation that is essentially paying the full salary of 20 or 30 assistant professors from their research grants. And so it's almost like the old German model where you have an heir professor that everybody in the department or whatever works for that one person. in medicine, it's very much moving to that model because it's the really big names that bring in the big money and are needed in order to support a fairly large number of assistant professors to get them over that period from the time they get their degree until they get their first R01 at age 40 or 44 or 45.
But those senior members, when they hire assistant professor, they are not tenure.
The assistant professor.
Yeah, if I'm a senior mentor and I'm hiring 3 or 4 assistant professor, and I know the medical school use that a lot because I see this at the Temple, they are non-tenure assistant professor.
Right.
Right. So, but what we're talking about, people are going to be going up the rank and they become full professor, and that's the challenge. But if you can support visiting research or research assistant professor, and the medical school do a lot of that. Yeah.
This is reminding me of a commission that President Obama put together. I don't think it's gotten very much attention, but it was looking at the growth or lack thereof of the scientific enterprise for the nation. Shirley Tillman, who's the president of Princeton and a scientist, is on it. Amy may be on it. Amy Gutman at Penn may be on it. There's a bunch of distinguished people on it. And they've issued a report basically says that the idea is totally flawed, that the scientific enterprise can continue to expand indefinitely. The nation has too many facilities, too many scientists, and as a direct result of that, hyper competition that's unhealthy for the enterprise. And yet, here we have 3 institutions that are hiring more scientists. And I'm sure that none of you want to look at a future where we have to accept the reality that this fairly distinguished commission stated that we're going to have to reduce the size. Can you imagine that, or any of you, can you imagine that? And what do you think the consequences would look like for the nation?
Tom, I agree with you completely. I think that
that's not me, that's the
I think that's inevitable. I think it's absolutely inevitable. I think that today, at least in chemical engineering, the cost of writing a proposal, or the cost of writing 20 proposals to get one funded, if the funding rate is 5%, exceeds the value, the cost of writing the proposals exceeds the value of the money that you get. And so the model has to change.
Yeah, but I take issue with this idea that the science and technology fields have to shrink for the good of the nation. I just don't buy it in a competitive global economy where the emerging economies are investing so aggressively in sciences and technology, and there are absolutely, I mean, there used to be a day where America, absolutely our universities are at the forefront. We have a wonderful legacy of intellectualism and creativity and implementation of science and technology to the good of society. But the rest of the world is also innovating and et cetera. Our economic well-being depends upon continued investment. And I've had wonderful conversations with people who ran startups in Shanghai and worked for major corporations and were brought into the States to make sure that we were picking up our pace. And so this idea that we can relent because we're too many and that we have to restructure, we have to find ways to support, but the idea that you cut back in response to this is, to me, nonsensical.
Well, there you have it, the realists and the idealists, right? I don't know about the rest of you, but I think I'm both of those things.
Well, you have to be creative also. I mean, that's the thing. I mean, there's a lot of things to be discovered and so the research is endless. And I mean, I remember I came 5-6 years ago, and I was sitting in a lab in an office and some empty boxes or something. Now we are 20 people, 7 of them are tenure track, so the university pick up their salary. And the rest come from the research contract, and doing all this has been really wonderful and really rewarding experience. But you have to be creative in hiring scientists.
In case you're worried, we are going to close precisely at 2 o'clock, so we still have about 15 minutes. There's a question that's been waiting patiently in the back.
I have a question. I'm Jeff Bornstein. I was Chief Operating Officer of the first company to get a license under the 1986 Technology Transfer Act, and also was in charge of commercial development and technology transfer at Tate & Lyle for 7 years. So I have a slightly different look at this as a chemical engineer and a businessman. In reversing it, I said, how do you prioritize or find the best opportunities out of the 100 opportunities or hundreds you get every year? And then do you select or would you select a particular company that you think is best to work with and then say, we're going to target them to get a grant or to work with because that fits the technology that we think has the most value?
You start.
Well,
Everybody you guys start.
let me mention about, I don't think really the tech transfer, and that's in my view limited in the last 5 years. They will go out there and identify and things. I think really things come on the scientist level and with networking. And then many times you bring them many of those interested party to your tech transfer. I don't recall, I mean, only once when they called me and said, do you want to have a spin-off company? And I said, spin-off of what? So that's why it's really, I think, on the scientist level and networking, that's what will bring you the partnership.
So there's not a single answer to your question, and academia is very diverse, and even within Johns Hopkins, we are very diverse. I can tell you that in engineering, we don't try to pick winners. So if, for example, there's a competition where the university has to provide a third or 50% matching funds for a particular grant opportunity, we will allow any faculty member that wants to apply for that opportunity, and if they get the award, we will pony up the third or 50% matching funds that are necessary. The School of Arts and Science at Johns Hopkins, though, does not do that. If you're in the School of Arts and Sciences in the Department of Chemistry and you want to apply for a grant that requires, substantial amounts of matching funds, often hundreds of thousands of dollars, you have to go and convince the dean that you are worthy, and then they will say yes or no, you can submit the proposal. And so it depends on where you are, the institution. Our School of Medicine is much more like the School of Arts and Sciences. They do not back all faculty. They choose sort of the people that get to apply and the people that don't. But in engineering, we have a policy that anybody can apply and we will find the money.
So I wanted to follow up with, if your idea is about how, with whom do we build relationships, I think right now, at least, to my knowledge, it's all very network and expertise driven. And so it's not been that there's been some organized sort of assault on US industry to find out who we're going to partner with, that it's been that we know that there are places which innovate in spaces where we're excellent, and that then you start the question, who do you know there, and how can we get started? And then these are questions of building trust and relationships. And so this is the other thing, that it's really important that contracts make it through the university in finite time. Because if there's a contract that fails to make it through, on one level you might look at it and say, oh, well, the dollar value for that contract wasn't so big. It's not that big a deal. But in fact, it's a severed relationship. There's somebody who was internal to that company that was a champion to try to move this forward and to plant new acorns from which mighty oaks might have grown. And so right now, it's very, to my knowledge, it's very much on that level. And so the faculty are very good at identifying opportunities, and then the university supports them developing the relationships to develop those opportunities.
I think I saw another one out here somewhere. Yeah, over there.
Kathy Unruh. I'm a medical device development from industry. And so one of the things that I've worked with Johns Hopkins, and Mark, I've had a wonderful experience with them, so I can take that to heart. But one of the things that we have, I think Mag did mention it before, is that we really want to look at products that are, or ideas that are closer to commercialization, because that IP or that idea is only a small portion of the overall product. And so one of the problems we have is we need to get that in the academic timeline is much different than the commercial timeline, and we need to get that academic timeline moved up for us so that we can get the rest of our product made so we can get to commercialization.
Go ahead.
You're absolutely right, and that's why I said, as I said, the example when somebody say, "You want to have a spin-off company?" I showed you 3 boxes when I said we build the. So I work with some faculty, very prominent professor, and we are in the first box, and they want to form a company and they want to do this, and I said, "Well, no, wait a minute. You have to go through all this so you get closer to what you say in order to be a valuable commodity." So this is something the academic try to learn about it, yeah.
So we refer to that space between discovery and sort of development of the first prototype or refinement of a prototype to a TRL-6, if you know what that means, as the valley of death. That it is almost impossible to get across it because the sponsors of the research very often, if it's the federal government especially, will not pay to develop something beyond the discovery phase. You can't get money from NSF or NIH to do that next step. If you're working with a corporation, quite often they will do that, but quite often they prefer to do that in-house. And the university, the way the university is set up, there just is very little internal money to do that kind of thing. I mean, we have a few $100,000 a year that we spend. Maybe across the whole university, there might be $1 million or $1.5 million, but that's peanuts. You know, I had an invention several years ago, and it went to a corporation, and I thought, well, you know, maybe I can do this on my own. I can, you know, do proof of concept myself. It turns out it took $50 million to do proof of concept and develop the first prototypes. There's no way that that ever could have happened in a university environment. And so I think perhaps the biggest opportunity for partnerships between academia and industry is in crossing that valley of death.
Yeah, right here in front.
I think some of the questions I was going to ask had been asked and answered, but I have a couple actually. One is a commenter and then the question. The question maybe for...
Who are you?
Kate. My name is Anbu Natesh, and I work for a company called Cordalite Corporation. Basically, we make product out of the cashew nut shell liquid, which goes into the various coatings and adhesives applications. Several years ago, I was a postdoc, and I did not have a green card at the time. And one of the projects funded by government, which is, you probably know the SDI, Strategic Defensive Initiative, then we made an invention, basically that became classified. And so basically, if you're a non-citizen, you cannot work on it. So that classified thing moved away from that. And I think what I'm bringing out is, Professor Donahue mentioned about most of your federally funded projects, or most of the monies are classified. How do you really, is it come as a classified, or you do actually once a project gets to a certain stage, it becomes classified?
I'm sorry, I didn't get exactly what the question is.
The classified projects.
Yes.
Basically, a classified project, you have a limited people can work on it, right? You cannot have anybody can work on the project.
Yes, I've had a great deal of classified funding myself, and have worked on a number of different classified projects. The university has rules that students cannot work on any classified project. And so when I work on classified things, I have to do it with either other professors or with full-time research scientists. And in my case, it was all done with full-time research PhDs who were very much like the PhDs that exist in a corporate laboratory. It's a different experience, but it can be very rewarding. I've had some of our discoveries briefed to the Joint Chiefs of Staff. I've had discoveries briefed to multiple vice presidents. I've never had anything that I know of that was briefed to the president, but these are things that are important in terms of national defense. And for me, that can be as rewarding as working on something that can be commercially valuable as well.
All right, last question. You get the final word. Well, they do.
Thank you. It's terrible to go again. There are all kinds of arcane things relative to not just classified military secrets. Certain information technologies are prohibited from being exported to certain countries, even countries that we generally think of as friendly. There are certain information technologies that can't be exported to Israel, for example. And those export rules then, a technology is deemed to be exported if it is taught to a citizen of that country. So if you have an Israeli student in your laboratory, an Israeli postdoc working for you, and that person is exposed to the critical information technology that the group is working on, then the group and the university can be accused of having exported the technology, which is against the law for being exported. So it's all kinds of crazy things you can get into.
Absolutely.
That wasn't a question. I think that's why they're not answering it. So I want to do two things in closing. One is I would like these three and me to thank all of you for your perceptive questions and comments. Thank you. I didn't ask you to clap for yourselves, but now would you please thank the three of them for such an excellent presentation. And now I think I'm supposed to turn it back over to Tom Lewis.
Thank you, Tom. And let's all thank Tom Tritton for his role here as the moderator. One of the things we do each year in planning programs for the JPS series is to have a planning session in which we put together the ideas for programs. And we're interested in your input to us on this. This is one in which there was a great deal more participant activity in the dialogue here with the panelists. And so this is a different venue than we normally have, but we're interested in your feedback on this type of a program. Normally, we have programs where the keynote speaker delivers a talk and we thank him at the end, but there's just a few questions. And so this is a different format. We're interested in your feedback and wish you the best for the holidays, and we will see you in January. Thank you.
Thanks, Tom. It was great. And Kate was, I don't know, I hope I give you